Welcome to my class Carbon and its Compounds Part 3. In this session, we will discuss what is meant by sp2 hybridization and what is meant by sp hybridization. Before watching this session, make sure that you would have watched Carbon and its Compounds Part 1 and Part 2. What is meant by sp2 hybridization? sp2 hybridization is nothing but intermixing of one s orbital, two p orbitals in the excited state is known as sp2 hybridization. In the sp2 hybridization, three hybrid orbitals are formed. Those three hybrid orbitals will have same shape and same energy but different orientation. Let us discuss the formation of ethene molecule where carbon undergoes sp2 hybridization. Let us consider sp2 hybridization of carbon. See, the excited state of carbon is 1s2, 2s1 and 2p3. Now, one s orbital and two p orbitals, that is 2px and 2py, intermixes to give three identical sp2, sp2, sp2 hybrid orbitals is known as sp2 hybridization. Here one s orbital is intermixing with two p orbitals, that is 2px and 2py. After hybridization, one pz orbital is left over with single electron without taking part in the hybridization. This is the electronic configuration of carbon in the hybridization state: 1s2, sp2, sp2, sp2 and 2pz1. Next, see this. Let us consider the orbital overlap in sp2 hybridization. See this one. 2s orbital intermixes with 2px and 2py orbitals to give three identical sp2, sp2 and sp2 hybrid orbitals, and one 2pz orbital is left over with a single electron without taking part in the hybridization. Now they are arranged at an angle of 120 degrees. So the shape of sp2 molecule is trigonal planar. Now let us consider the formation of ethene molecule. There is a sigma bond between sp2 and sp2 hybrid orbitals of carbon. A sigma bond is formed between two sp2 and sp2 hybrid orbitals. Next, the remaining two sp2 hybrid orbitals of each carbon takes part in the bond formation with s orbital of hydrogen. See this one, with s orbital of hydrogen. So here two covalent bonds, here also two covalent bonds are formed. Next, there is one unhybrid orbital, that is 2pz orbital in each carbon atom. This 2pz of one carbon atom and 2pz orbital of another carbon atom overlaps parallelly, because linear overlapping is not possible here. So they overlap parallelly and a new bond is formed, that is a pi bond is formed here, okay, between 2pz orbitals of unhybrid carbon atom. Next, this is the final structure of ethene molecule where carbon undergoes sp2 hybridization. Here the bond angle is 121.3 degrees. Okay, next. Next, let us consider sp hybridization. One s orbital and one p orbital intermixes to give two identical sp hybrid orbitals is known as sp hybridization. After hybridization, two p orbitals, that is py and pz orbitals, are left over without involving in hybridization. Now look here, the electronic configuration of carbon here. This is 1s2. Now already I told you one s orbital and one p orbital are intermixing are intermixing. That is, here see this one, 2s1 and 2px1. These two orbitals intermixes to give two identical hybrid orbitals, that is sp2 hybrid orbitals. Now after the hybridization, one electron is left over in each py and pz orbitals. So this is the final shape of sp hybrid orbitals. See this one, they are arranged linearly, so the bond angle is 180 degrees. Let us consider the example of formation of acetylene molecule or ethyne molecule. See this example, see this here, when two carbon atoms comes close together, that is sp hybrid orbital of one carbon and another carbon overlaps linearly, a sigma bond is formed here, a sigma bond is formed. Next, 2py orbital of one carbon, 2py orbital of another carbon are overlapping parallelly and a pi bond is formed. Look here, 2pz orbital of one carbon and 2pz orbital of another carbon are overlapping parallelly. So another pi bond is formed. Altogether, in the formation of ethyne molecule, there are triple bond. There is a triple bond between carbon carbon. One is sigma bond due to the linear overlap of sp hybrid orbitals. Next, two pi bonds due to the parallel overlap of 2py orbital and 2py orbital and 2pz orbital and 2pz orbital. And the remaining one hybrid sp hybrid orbitals overlaps with s orbital of hydrogen atom. Look here, a sigma bond is formed. Sigma sp S here. Here also sigma sps, a bond is formed. So this is the formation of ethyne molecule. This is the orbital overlap of ethyne molecule. Look carefully, this here a sigma bond is there between carbon carbon and two pi bonds are there. So between carbon carbon there is a triple bond in ethyne molecule, and the remaining sp hybrid orbital overlaps with s orbital of hydrogen. See, this is the final shape of ethyne molecule or acetylene molecule. Thank you, children. If you like my video, please subscribe. Don't forget to watch my lessons. Thank you.